Topic 1.1, as we're finishing up the application problems, we did go through some solving equations. Remember that? I'm not going to go through them all. We did different types. You know, I will touch on a couple things. If you ever can clean up or combine like terms with something on one side of the equal sign, let's do that before you start flip-flopping, moving stuff around. When we turn the page, we did talk about solving equations with fractions. So the best thing to think of is if I see some fractions in there, I want to get rid of the denominator in the first step if possible. There's a problem in there in your homework that kind of looks like this one, but then has like a +2 over here. We can't butterfly that one, okay? So when you're working on your homework, just remember, I can't butterfly that one. I have to get rid of the denominator by multiplying by whatever a least common multiple would have been, or least common denominator would have been. You're going to also notice there's a negative in the bottom. This is just a little tip I'm giving you, so if you want to write it down, you can. But like I would multiply everything by a negative, so you're not dealing with some sign issues. So like for the problem I had a -3 and a 5 in the denominator, and then a whole number over here. I would multiply it all by like -15. That's just my suggestion. If you need any more help, let me know. But if it is one fraction equaling another, we can definitely butterfly. It makes it easy and fast. Then we went through absolute value equations. So remember when we're working with absolute value, that's the distance from 0 on the number line. And so because of that, we have to make two equations. A couple rules that we went over with that is if you have the absolute value bracket isolated already, we can never have it equaling to a negative number. We can't make two equations when it's given to us with a negative. We have to say that's not possible because I can't move. There's nothing that you could put in here for x that would make that a -2 because of the rules of absolute value. The other thing I want to touch on is we always want our absolute value bracket by itself. Okay, so like this one looks pretty busy, so we need to think, I want to isolate that absolute value bracket first. Common mistake is to treat it like a parentheses and try to distribute that 2 through. Don't do that. Okay, let's get that absolute value bracket by itself, and so since there was a constant, we moved it, then we divided. So then we could look to see if we can solve, which we can because that's positive, right? So we can make our two equations and solve for our two x's. So let's look at the two application problems that went with those types of problems. I'll zoom in just a bit more so you can see. So just remember, something they assume you know is that your distance equals your rate times your time. So let's just kind of remember that. I think we'll actually be working with that a little bit more later, but so the numbers of miles that remain to be flown by a commercial jet traveling from Boston to LA can be approximated by this equation. So they're giving it to you, miles remaining equals that 2650 minus 475 t. T is in time, where t is the number of hours since leaving Boston. How many hours will the plane be 1,000 miles from? So miles remaining, right? 1,000 miles from LA, round to the nearest 1/10 of an hour. So we know they give us this. This is distance is 1,000. And I already kind of like tell you exactly what's happening. Miles remaining, that's your distance, right? So we're just going to plug 1,000 into that and solve for time. So this one isn't absolute value. It's just a word problem and replacing for the value that we have in solving. So 2650 minus 475 t. So what do we need to do first? Wake up. We can do it. Move 2650, right? How do we move it? Subtract. So 2650, subtract 2650, so that zeroes out. So on the left, you have a negative 1650. Don't forget over here, there was a minus sign in front of that 475, so that's like a negative 475. Otherwise, it's going to look like you have negative time. Can you have negative time? No, that wouldn't be a reasonable answer. So when you went back, you'd be like, what did I do wrong? Maybe just forgot a negative. So let's divide by negative 475. And so I know a negative divided by negative is a positive, so like when I'm entering this into my calculator, I personally am just going to type in 1650 divided by 475, and it says to round to the nearest what? Tenth of an hour. So I know that this goes on and on and on, but I'm just going to write down two numbers because I need to look at the second to decide what happens with the first, right? This is the 10th. The number I just circled is in the 10th place. So am I going to round that up or keep it the same?
No.
Round it up. So we're going to say 3.5 hours is our time. You don't have to worry about labeling time in WebAssign. Things are going to already, or labeling anything really, it's already going to be labeled for you, but you should be in the habit of doing it when you're doing your written work. Okay. Try to, that way, I want you to kind of look back. Does that seem reasonable? 3.5 hours. It's a real time. So yeah. It's not negative, 3.5 hours, so. Okay, let's look at number 14. So Alicia is driving along a highway that passes through Centerville. So we got Centerville right here. Her distance D in miles from Centerville is given by this equation. So we could be before or after Centerville, right? So that's why we're doing a absolute value problem in this one. It says where T is the time in hours since the start of her trip. This is really just giving you kind of like a standard to go by, for instance. Like it's going to be somewhere between 0 and 5 hours. That's why they have T in the middle. So that's just an inequality stating it's between 0 and 5 hours. So we want to determine when Alicia will be exactly 15 miles from Centerville, and we're going to say that either before or after. We're just going to go with both of these, so that way we're not deciding, well, are we before? I would think from would be before, wouldn't you? 15 miles from Centerville, but maybe somebody say you went past it. Well, we're 15 miles past it. I don't know. We're going to use both as our answer, though, just not getting that detailed. So we're saying D is distance, and they said we want to know we're 15 miles away from it. Let's just say that, 15 miles. So I'm going to say 15 equals the absolute value of 135 minus 60t. So can we solve this absolute value equation? Yeah, we can just jump right in because the bracket's already by itself, and this is a positive number. So we can create our two equations. 15 equals 135 minus 60t. And then your other equation would be negative 15 equals 135 minus 60t. So the only thing that this looks different compared to the problems we did on the page before that weren't application is it's mirrored, right? The 15 was on the left, and like the expression part was on the right, so it's just opposites. So all we're doing now is just solving. So we would subtract 135, since t's on the right, I want to leave it over there. So subtract 135 from both sides. So 15 minus 135 is a negative 120. Equals, again, remember we got that negative in front of the 60, so negative 60t. To finish solving for time, we're going to say divided by negative 60. So negative divided by negative makes that a positive 2t. So 2 hours. From Centerville. Let's see how much. Oh, it will take 2 hours. It will be 2 hours once she gets 15 miles. That I said that way wrong, didn't I? So once she gets started, it's going to be 2 hours before she's 15 miles from Centerville. Let's do the other one. So we would still subtract 135. So since they're both negative, you're actually adding and you get a negative 150. Again, this is a negative 60. So divide by negative 60. So when you divide that, you get a 2.5, positive 2.5. I'll always show you the calculator because I assume you know how to use it, but 2.5. Sometimes when we're doing other stuff, I will show it to you when there's other functions that are harder than that. Hours. So I would say if you're deciding, this would be, it would take you 2 hours to get 15 miles before Centerville, and then if you're going to drive past it, that would mean you'd be in the car for 2.5 hours. You're not going to have one exactly like that, so you don't have to decide if one answer or both answers is going to be what you choose. We're just going to say if you're 15 miles before or after, it's either you've driven for 2 hours or 2.5 hours. That's all that one will be. Personally, if I was really getting picky, if I said then it would be 2 hours, right? The shorter time. I think longer to get before it, but. Okay, then just in recap, we solved some literal equations. Sometimes be careful with your entering tool. I know somebody had some issues, but they figured it out on one of the problems where they were isolating, I believe it was this one, and it was just entering it in. They had all the answer right, but it was not reading it, like there was some kind of weird notation you were doing in there. So do your best. If you ever struggle entering it in, maybe send me a picture of it or something so I can look at it. I'll know to go look at yours if you can't ever get it to work right. I don't want you to get it wrong just because of how you enter something into WebAssign. But we do have an application problem down here. So we're assuming that you guys kind of remember that the perimeter formula in this, okay? So sometimes there's some assumptions that they believe you remember. I'll try to remind you of it. But when you're doing any word problem, we really should read through it carefully. I like to, as I go, write down the given information. Sometimes you might want to draw a picture. Sometimes that helps you process it, or some sort of chart. Then kind of decide, how am I going to solve this? What's my strategy? How do I think I'm going to do this? Look at all the given information to figure that out. Write that equation if you're writing an equation and solve it. But in the end, it's really important that you always ask yourself, is my answer reasonable? So let's take a look at number 8. It says the length of a room is 9 feet less than twice the width of the room. The perimeter of the room is 48 feet. Find the width, then find the length of the room. So we know, again, we're talking about perimeter, and it sounds like it's a rectangle shape. If you don't remember the formula for a like a rectangle shaped room, remember you have two lengths, right? So we're going to take P equals 2 times L. Actually, I might write it down here. I'll write it in both places. We have 2 lengths and we have 2 widths, so plus 2 widths. Because remember, perimeter, you're adding all the sides together. Well, rather than writing L plus L, W plus W, we can write 2L plus 2 W's. Well, some of the given information we know is that the perimeter, the P part, is 48 feet. So let's say P equals 48 feet. This part, we're going to make an expression because it's a little bit wordy. Anytime you read the word less than, what you read second actually comes first, because it's like saying less than this. Well, this comes first, then you'd have to subtract it, okay? So if it says 9 feet less than twice the width, we know twice the width would be like 2W. And if it's 9 feet less than, then we'd say minus 9. Just kind of squeezing it up there, but your less than makes you put that part behind what you read next. So down here, I know that's squeezed really tight. I'm going to clean that up and write, that means my length, because it said the length of the room is So length equals 2W minus 9, because it's 9 feet less than twice the width. So actually we do have enough information to go solve this now. Okay? If I know my length is this, I can go plug that in for L. And if I know my perimeter is this, I can go plug that in for my perimeter, right? So really the only unknown now is W. So let's put maybe a line there to separate it if you need to. Let's do that. We're going to say 48 represents my perimeter because I know that measurement. I'm taking 2 times my length, which was an expression, 2W minus 9. And then bring down the plus 2W that was left in your perimeter formula. So now it looks a lot, we can go solve for some W's, but what would we do first? There's a parentheses. Distribute, yeah. So we have 48 equals 2 times 2W is 4W. 2 times negative 9 is a negative 18. And then we need to bring down plus 2W since it was separated by that plus sign. Can we clean up the right-hand side? Any like terms that could be combined? Yeah, 4W and 2W. So keep 48 the same. Let's bring it down. 4 and 2 make 6, so 6W. Remember, you're just combining like terms. They didn't move. Keep them the way they are and combine them. And then minus 18. So since the W is on the right, I'm going to keep it there and move 18 over. Am I going to add or subtract it? Add it. So 48 plus 18 is 66. 6 equals 6W. So what is W? 11. So we'd have to divide by 6. So 66 divided by 6 is 11. Remember that represents 11 feet is my width. So it's pretty easy to go find our length now because we need to know both. Find the width and the length. I know my length equals 2W minus 9. So I'm just, now that I know my W, I can plug that into my width. So 2 times 11 minus 9. You can do the steps, or you could also probably just plug that into your calculator, but 22 minus 9 is 13. So 13 feet is my length. I feel like there might be one like that in your homework. So if you weren't sure how to do it, put a star by that one. Come back and look at that one when you're finishing up your homework. Any questions? Okay. Let's turn the page. We have some more word problems. So quickly, I think you probably know your profit is always equal to whatever your revenue is, like whatever money you take in, your revenue minus whatever the cost was. That's all. That represents your profit. Here's a fancy way that they write it in a formula that you may see it sometimes. P of X. Remember, that's just like if you knew what the profit was, you would just put it there. Okay, whatever that is. And they're all affected by each other in some way, depending on what you're working with. So your profit, your revenue, minus the cost. That's simply what it is. Your interest formula is your interest equals your principal, like whatever you're borrowing or investing, depending on what you're thinking about with interest, times whatever the rate is. That tells you how much interest you earned if you invested, or how much interest it's going to cost you to borrow. So just kind of going over those very briefly, let's talk about number 9. It costs a tennis shoe manufacturer $37.15 to produce a pair of shoes that sells for, I'm writing $69.95. So if something sells for it, you would call that the revenue. So I know in some ways, verbiage, when you're a buyer, you're like, how much does that cost? Well, that's because that's what you're paying. But like, let's get in a marketing, mindset for a minute. It's going to cost you something, then you're going to sell it for more. Okay, so the cost is $37.15. The revenue would be $69.95. How many pairs of shoes must the manufacturer sell to profit? Profit, it says it right there, the $20,172. So we just know that we're taking our profit. We can get away from the busyness of the P of X, if you want, equals whatever the revenue is or whatever you're selling the shoe for minus the cost. And we don't know how many pairs of shoe are, so we're going to say X equals pairs of shoes. That's what we don't know. That's what we want to find is X. So I know I want to make $20,172. I know it cost me $69.95. Or not cost me. I know I'm going to sell it for $69.95, but I don't know how many I'm going to sell, so let's put an X by it. Because we don't know how many are you going to sell at that price. X. We don't know yet. That's unknown. Minus the cost of $37.15 X. Because, again, how many are we saying that we sold? So then, to solve this, what would you do? Combine like terms first, right? Are these both X's on the right? So basically you're just finding what is the cost per shoe, and then you're going to divide, and that will tell you how many. So $69.95, let's turn my calculator on. $69.95 minus $37.15 is $32.80. So $32.80 X. And then we have that 20,172. And then to find how many pairs of shoes would profit you that, you just divide by 3280. So $20,172 divided by 32.8 is $615. So you'd need to sell 615 pairs of shoes to make that profit of $20,000, $20,000+. Now, sometimes in word problems, all of our minds might work just a little bit different. Totally okay. Since I'm the teacher, I'm going to show you how my mind works. And since I've been teaching this for so long, I think it's the easiest way to teach it. If you notice in this problem, I have like a 3x3 box. It's going to help us organize some information above. Then we can create two equations and go solve a system of equations. Hopefully you kind of remember that. If not, we'll review that as we go. But in this problem, we're talking about an investment. A person invests part of $5,000 into a 4% account, simple interest account, and the remainder in a 6% interest account. Together, the investments earn $270 per year. Find the amount invested at each rate. So for me, there's a lot less thinking if I set up two different equations. P represents my principal. How much am I going to invest? This X right here, and Y means one account I'm just going to call X. The other account I'm going to call Y. Okay, and we know that principal times our rate equals our interest. So if you put that above, in this case, it might help you a little bit with organizing what goes in what box. How much am I investing total?
$5,000.
Total of $5,000. We don't know how it's going to be divided. That's what we're trying to find. How much did you put in the 4%? Maybe X. How much did you put in the 6%? So we're going to put that down here. You might think of this one kind of like a total column, sort of. R is the rate, the percentage that you are earning in this case. So if we're talking about 4%, remember when we're doing math, can you work with percentages as they are if you multiply? What do you have to do with a percentage? What do you have to convert it to?
Decimal.
A decimal. So we know there's an understood decimal here. If we just move it 2 places to the left, I won't always do this, but it's just a reminder. You just slide that 2 places, and that means that's the 0.04. So 6% would also be 0.06, and that would be kind of in that same row as the Y's. So this is, X is representing the 4% account, and Y is representing the 6%. I want to make a total of $270 in interest, right? That's what we want to earn, and when you're investing, interest is what you're earning. So that will be down here in this total column, $270. So when you're working with like an interest problem, you'll never have anything here. You can just kind of swivel it. There's never anything in that one. Over here, it's like you're multiplying these two together, and so that would be like saying 0.04x. See how I show you that you're multiplying anyways? So read it the same kind of way. And we have 0.06y. So what we do from here is this makes an equation, and this makes an equation. Okay, you can circle it or however you want. I went ahead and just highlighted it. And what you do is you think from top to bottom, we're going to take x plus y and set it equal to that total row of 5,000. Same over here for the second one. You're working top to bottom, and we're going to say 0.04x plus 0.06y equals 270. So if you remember about system of equations, there was something that was called substitution, which we technically did when we were working that perimeter problem, right? We substituted length into it. So what we would want to do is in this first equation, they'll all be like this. You always have like x plus y equals something when you're working with these types of problems. I almost always move y over and isolate my x. You could isolate your y, but I just am choosing to tack minus y on at the end and say x equals the expression 5,000 minus y. So just like that perimeter problem we did on the page before, I'm taking x and plugging that into that second equation. I'm taking this expression and plugging it into x. So let's do that. 0.04 times, we're saying 5,000 minus y. So we replace that. Plus 0.06y equals 270. So it might seem like a lot of steps leading up to that, but I promise you the chart kind of helps you organize information. Then you can easily make the two equations. Then let's get a variable by itself and set it up. Let's substitute it. Now we need to go distribute, right? So what is 0.04 times 5,000? I think it's 200. Just to eliminate calculator work and be a little bit quicker, I'm just going to give it to you. 0.04 times negative y is a negative 0.04y. And then we can bring down all the other information that we're not working with yet. Remember to stay organized, it helps a lot. What can we combine now? Like terms of the y's, so I have 200, a negative 0.04, and a positive 0.06 is a positive 0.02y equals to 70. Now let's get y by itself. Let's subtract 200. So 0.02y equals 70. What's our last step? How do we get y by itself?
Right.
Divide by 0.02. So y equals 3,500. So remember, you have to remember, what did you assign y to? What percentage? Which account was that?
6%.
The 6%. So you can go back up to your chart and remember, because when you answer those in WebAssign, it does separate. It doesn't say x equals this or y equals this. You have to remember that y represented my 6% account because it's right beside each other in that chart. So you could just say 6% account. So finding the 4% account is pretty easy, right? We could just say, we know x equals 5,000 minus y. Well, since we know y, all we're doing is taking that from 5,000 to know how much you invested in the other account, which was what? 1,500. And that was in the 4% account. So you do have to know how to solve systems in algebra. In this section, we don't do it a whole lot, really just for these two application problems. Hopefully it'll kind of be enough review for you, especially when we go to that unit where we do a lot more solving systems. We're going to do another one so that you can kind of read and see how you'll do that same step through another problem that's similar but a little bit different. So this one was like a business type application problem, talking about money, which we all love. Let's turn the page and we're going to talk about like a science application of this. So it's talking about to form a 10% copper alloy weighing 75 grams, a 6% copper alloy is combined with an 18% copper alloy. How much of each type should be used? So we're still talking about two different things, right? A 6% and an 18%, but in this case, we're trying to form a 10% alloy weighing 75 grams. So we know the rate is here. You're not going to have your formula, your percentage is here. We're going to be talking about grams. So we want to create, this is what you're creating. So your total line, you want to think, this is what I'm trying to create. So I know I'm going to try to figure out how much of the 6% and how much of the 18%, how much each of those we're going to use to make 75 total grams. So let's put 75 right there. And I want it to be a 10% copper alloy. So this is all representing the same thing. So 10% would be 0.10 or just 0.1. It doesn't matter which one you give to X or Y, but since I'm doing it, I'm going to just say my 6%, the one that I said first, is going to be my X. 18%, 0.18 is going to be my Y. So this one is a little bit different, so you do use that bottom middle box. Since you're combining something to create something new that has a different percentage. So all your percentages will always be in the same row. So if you're ever like, how do I know to put 10% there and not there? Because these are all percentages. That might be a good memory device. Okay, so then you're going to still multiply across like we had been on the other one, 0.06x, 0.18y, and 75 times 0.1 is 7.5. So you're still creating two equations from your first and last columns. So you'll always add the first two and set it equal to the bottom one, just like we did on the other one. So my first equation is x plus y equals 75. My second equation is 0.06x plus 0.18y equals 7.5. Sometimes, guys, instead of the percentage, it's going to tell you a cost, which is like the word problem in your homework. It's going to be similar to this one, but where you have the percentage, you might put the money. So sometimes it can say, I want 75 grams of this that'll cost $3. But if it was this amount, so you might, however it's rating it, that's why I went ahead and left the R there, like it's rating it by money or percentage. That's what you're doing in that column. Okay, so what do you think we'll do now? What do we do over here first?
Check the Y.
Yeah, we like isolated X or Y. I'm going to keep isolating X just because that's what I like to do. Since I'm teaching, that's what we'll do. You'll get the same answer and it'll still go with the right letter if you do it the other way around. So we have X equals 75 minus Y. So remember, this is the expression we have that represents X. We're going to take that and put it into X in the other equation. You guys are doing great. Stay with me. 0.06 times 75 minus Y. And then copy down the rest of that. Plus 0.18Y equals 7.5. So 0.06 times 75, if you put that in your calculator, is 4.5. 0.06 times negative Y is negative 0.06Y. Plus 0.18Y equals 7.5. So just like on page before, after you distributed, I like to show this because this is how you can look at notes and see how you do one that is similar but not just like yours, right? Same steps. So see how we're at this step now. You combine your like terms like we did on the previous one. So that's all just solving equation stuff that we reviewed prior. 4.5 and negative 0.06 and a positive 0.18 makes that a positive 0.12 Y equals 7.5. 1200ths Y. So since Y is on the left, I want to move 4.5 to the right. We need to do that by subtracting. Since it was positive, we want to say minus 4.5 so that it zeroes out. So 7.5 minus 4.5 is 3. You could put 3.0 if you really like to see it as a decimal since that's what it is above. Divide by 0.12. And so let your calculator do all that work for you so you don't get a decimal place wrong. So Y equals 25. Remember, we're talking about weight. X and Y is representing the weight of this copper alloy that we're going to use. We're going to use 25 grams of it and combine it with another amount of grams to make the 10% that it weighed 75 grams in the end. So how do I go find my X? Pretty easy. Just say minus 75 minus that. So I'm going to put that there so you remember. So to go find the X, we're going to say X minus, or X equals 75 minus 25, which is what? And then remember, how do I know if which one represents the 6% copper alloy and which one was representing the 18%? I'm going to zoom out. Let's go back to our chart. And we had 6% with the X. So this was the 6% copper alloy. And then the Y was your 18% copper alloy. So you got to do a little chemistry here. You have to mix to create a 10% that weighed 75 grams. Again, a word problem in your homework is going to talk about something that I think is maybe weight, but it's not going to talk about a percentage, it's going to talk about cost. And that's where you're going to put that here. So it's not exactly like what we did in our notes, but it's similar, okay? And if you have trouble, just let me know, and I'll try to guide you, help you at least set it up, but I would like for you to try to go through the solving steps on your own. So that finishes up your the notes for that part, the 1.1 through 1.2.